Okay, we're back.
Okay, we can hear you.
Okay, it's better?
Okay, I'm gonna turn off the call from the WhatsApp.
Okay, bye.
Cool. Okay, so I hope you're not gonna.
Can you see this screen?
Yeah.
Yes, we can see it.
Oh.
Okay, so I'm gonna switch the main screen to the one of Tehran.
Okay.
Okay. Good. So hopefully it's gonna work. In case it's not working, it is absolutely normal. And if you don't think it's normal, you should be part of the IT program at the Hub Academy more often and see how many problems we can have when we are trying to connect people from all around the world. So I don't want to waste this magic moment of connection. Introduce your speaker, and we can start the lecture. We see you.
You can see me?
Yes.
You can start the lecture if it's okay with you. Can you hear me?
More or less.
I can hear you.
Good. Okay, so you can start.
Okay. Hi everybody and welcome to summer school. My name is Nashid Nabian. I am an architect both by education and profession. I partner in an architectural office based in Tehran called Shift Process Practice, and I am one of the researchers at Tehran Urban Innovation Center. And today I'm here to share with you some of the preoccupations of our center, a research by design and design by research platform for creating novel urban solutions to pressing issues of Iranian cities. The talk is on digitally augmented environments, responsive architectures, and interactive objects. And we'll cover some basic information about objects and architectures with cybernetically driven behavior to digital augmentation and situation. And these are the objects that we believe that can transform our lived-in environments and everything in them from inert constructs to responsive, context-aware systems. Digital augmentation deploys novel technologies to merge a built environment with digital information so that it is dynamically sensed and synchronously actuated to perform more efficiently, intelligently, and sustainably. Contemporary digital culture has influenced our spatial thinking to the point where the digital is not a substitution for physical, but augments and enhances it to create realities consisting of physical and digital layers that are cross-referenced with the aid of technology that is the subject of today's talk. By cross-referencing the digital and physical world, all manipulations of both worlds can be done in correlation and coordination. This type of research is significant because a lot is changing in how we produce and consume our spaces of urban life, and this is well manifested in new technologies new terminologies that are constantly surfacing in our urban and architecture-related discourse, ranging from conceptual frameworks such as variable computing, augmented realities, smart materials, or tangible interfaces, to well-branded technologies that we deploy on a day-to-day basis, such as virtual platforms like Twitter, Facebook, Instagram, and YouTube, or actual technologies such as broadband internet, Wi-Fi wireless connection, interactive digital screen, and of course, GPS locationing. This technocultural paradigmatic shift allows for artifactual, architectural, and urban solutions that are aware of their context, are capable of renegotiating their goals based on emergent conditions, of soliciting their inhabitants' dynamic needs and desires, and of transforming into mediating fields of urban interaction. The interaction, of course, can be orchestrated between individuals themselves, the inhabitants of built environments and the constituting elements of their environments, and the citizens of the city and their shared open urban spaces. Are you guys online still? Hello?
Yes, I am.
Okay.
Yes, we are here.
Because it was like disconnected for a second, I think that
Our microphone are mute locally in order not to create noise. Okay.
Okay.
We are all here.
Okay. So no need to mention that thanks to mobile technologies, now we have the capacity to administer the transmission and reception of digitally encoded interactions between all these players remotely, as well as having them respond to each other locally. The sort of objects and spaces that allow for such interactions, these digitally augmented artifacts, architectures, or urban environments, are temporalized entities. They are subjective and subjected, and they are technologically enhanced, and finally, they are or can be networked. But what I mean when I claim that such spaces are temporalized? Throughout history, architecture has primarily been about erecting durable structures that resist the degenerative impact of time. In digital augmentation scenarios, however, time is generative and pregnant with perpetual eventfulness. Therefore, the designer designs for ephemeral spatial relations that unfold over time, as opposed to substantial spatial compositions that resist time. Hence, what is at hand is a transformation of our design approach from designing things that are durable, solid, fixed, inert, non-responsive to change, and substantial, to things that are ephemeral, capable of transformation, responsive to change, interactive, and less or non-substantial. In his introduction to the book Architecture of the Well-Tempered Environment, Rainer Benham criticizes a history and definition of architecture that focuses on durable and solid structures that primarily mean as inert objects. In contrast to this tradition, he points to societies that do not build substantial structures, noting their tendency to group the activities around some central focus, for example, a campfire, and to inhabit a space whose external boundaries are vague, adjustable to functional needs, and rarely regular. One can easily claim that this conception of architecture of campfire serves as a model for the design of digitally augmented artifacts, architectures, and infrastructures, and for exploring ways to supplement physical environments with non-substantial architectures that modify and enhance their perception and performance. This is achieved by embedded technology that enables the deployment of virtual constructions in real space. The aim is not to dematerialize the building, but rather to exploit the synergetic alignment of architecture with ephemeral, formless, and non-substantial feature of digital technology. Or to use MIT Media Lab Hiroshi Ishii's formulation, to pair bits with atoms. The physical artifact architectural environment is augmented with a layer of digital information that is temporal by nature, because it is a pattern of zeros and ones, creating a rhythm of absence and presence. In this case, the focus of design has primarily shifted from the spatial allocation of substance to the temporal allocation of non-substance or information, where the augmented entity is endowed with different temporalities: absolute time, relative time, looped time, when processes are programmed to repeat at certain intervals, recursive time, when each loop is slightly different from the previous one in response to some change in contextual information, real time, when multiple processes are programmed with some level of synchronicity, and reversible time when we get access to the recorded log of some past processes in the present. Such augmented entities are sentient machines for habitation, registering emerging conditions and synchronizing a response accordingly. Once artifacts, architectures, or environments become context-aware decision-making entities, the subject is incorporated as an entity with transient needs and preferences. The subject becomes a hyper-individualized user instead of a predefined generic inhabitant in the case of an augmented architecture, or object handler in the case of an augmented artifact. This user is hyper-connected through telecommunication technologies, ultra-mobile by aid of transportation boosts, extensively subjective because of the information revolution's democratization of knowledge, hyper-individualized as a result of her desires being constantly solicited by new technologies, and of course, she's going to be very digitally extended. Ideally, our digitally augmented artifacts, architectures, and environments, these sentient machines of habitation, are networked. The extreme vision is a Pandoran world of hyperconnections where all entities are connected through space and time by hierarchical infrastructures or peer-to-peer ad hoc networks. And this network possesses a complete digitized memory of the past enhanced with pattern recognition algorithms that allow for anticipating the future. Hence, temporal and spatial distances are bridged between the augmented entities and their users, and this gives the vision of a world of total recall and a world of hyperconnections, otherwise known as the Internet of Everything. Whereas in its earlier iteration, the hyperconnected world was envisioned as the Internet of Things, things being the smart, context-aware artifacts, architectures, and infrastructures. The Internet of Everything adds to this mix the connected users that have the repository of that digital information on the global net on their disposal, tapping into it whenever and whatever with their smartphones and operating on 4G and 4G-like networks. The technologies that facilitate digital augmentation are technologies that acquire information from the space of habitation, meaning sensing technologies, or technologies that deliver information back to it, actuating technologies, technologies that bridge spatial distance or connectivity technologies, technologies that bridge temporal distance or memory storage and management technologies, and finally, technologies of geolocalization that allow layers of delivered information to be situated within the physical landscape that they augment. They transform the augmented space to a real-time locality or a geotaggable, geocacheable space where the physical and digital terrain are connected by information placeholders with known geographical locations. In what I define as real-time localities, the virtual representation of space is the interface through which information is acquired and delivered, like a dynamic interactive Google map populated with placeholders for various real-time information accessed by a sedentary user behind the computer screen. In what I identify as geotaggable, geocacheable space, the physical space itself becomes the interface for the acquisition and delivery of digital content. Agents geotag and geocache information dynamically based on their real-time locations. This is the case for almost all location-based services, also known as augmented reality platforms, which allow users to access relevant information via their smartphones while on the run and navigating the city. In such locative data-driven media, information is navigated through space and time both, meaning that you can fast-forward or rewind the narrative by changing position in the city. The extreme actualization of such augmentation scenarios culminated in the not-so-successful commercialization of Google Glass. in his 2006 sci-fi novel Rainbow's End, Werner Winch depicts a series of technological advances suggestive of speculation that the world is ongoing and ever-increasing change, perhaps destined for a technological singularity. The technological singularity, or simply the singularity, is a hypothetical moment in time when artificial intelligence will have progressed to the point of a greater than human intelligence, radically changing civilization and perhaps human culture. At the same time, augmented reality is dominant in the novel, with humans interacting with virtual overlays of reality almost all the time. In this close-to-reality fiction, this is accomplished by wearing a smart clothing that provides gesture recognition and contact lenses that can overlay and replace what the eye would normally see with computer graphics using advanced retinal display or VRD already commercialized. And in addition, haptic feedback is made possible by overlaying graphics onto a physical machine such as a robot. A closer look of the technological trend and rapid commodification of high-end, multimodal, high-resolution AR devices leaves us no choice but to accept that this is not a fiction anymore, but a fictional reality. The question is, if the day is soon coming when users of augmented reality devices will be able to render and project alternative realities back to their own field of vision and create individualized, informatically driven spatial experiences, where will this leave us architects and urban designers? Will this have an impact on how we conceive of, design, and build our habitable environments? Technologically enhanced possibilities for the consumption and production of space generate a certain tension in contemporary architectural and urban design-related discourse. Given the emergent, technologically driven paradigmatic shift in how we design, build, and inhabit the space, what is our role as architects, urban designers, landscape designers, and basically as individuals involved in spatial practices? Citing Rudolf L. Curry, Dean of School of Architecture at Miami University, I would like to draw your attention to these two projects. The Monoliths by Jean Nouvel and the Bloor Building by Diller and Scofidio, both showcased in the very same event, the 6th Swiss National Exposition in 2002. The twofold can serve as a perfect example to illustrate this dialectic. One reaffirms the object of architecture by retreating into a fundamentally Platonic recognizable form. The other is an open-ended formless field with no clear extremities and diffuse boundaries. One exemplifies the autonomy of the architectural object. The other is a networked system of a very sophisticated intelligent chain of computers that regulate all the critical moments in the construction of a very strange atmospheric event. One is very much about hardware, the other is driven by software. One is clearly a room, the other is about atmospheres. One is creating a space for an event, the other is preoccupied with the temporal deployment of that event. The tensions in this dialectic are latent in any contemporary work of architecture, combining the digital and physical realm. A good example is Jean Nouvel's blue cube wrapped in translucent wires that transform its exterior surfaces to a big computer screen. It tends to dematerialize and act like an interface communicating information. At the same time, it establishes its condition as an architectural object. We can say that it is an architectural interface, a hybrid spatial construct, born out of recombining the virtual and the physical. Augmentation and illumination. Augmentation and illumination are two common techniques for transforming inert architectural surfaces to active, context-driven architectural interfaces. To this list, I would like to also add some more techniques. Projection is another one to consider. The conception of a projected media facade project consistently derives from its underlying architecture. In the context of the 555 cubic, that would be the theoretical conception and visual pattern of the strict architecture of O.M. Unger's Galerie de Gegenwart. The building is in Hamburg. The basic idea of narration is to dissolve and break through this strict architecture. Resultant permeability of the solid facade uncovers different interpretations of conception, geometry, and aesthetics expressed through graphics and movements. A situation of reflexivity evolves, one that describes the constitution and spatial perception of this location by the means of the building itself. Just go forward, this one. Okay, thank you. Another North-Forsey technique is that of kinetic actuation, where the architectural surface is conceived as an array of physical pixels. In digital imaging, a pixel or picture element is the smallest unit or element in the display device. It is the smallest controllable element of a picture represented on the screen. The address of a pixel corresponds to its physical coordinates, and the pixel has a finite set of a discernible state. The number of constitutive pixels will control the resolution of the overall raster image, and the number of its states allows for enhancement of modality of the image that it conveys. If we think of the constituting elements, of architectural facade as physical pixels with finite number of states, controlling the alteration of the physical pixel between these finite states will allow us to transform the architectural surface to an architectural interface. An interface that is capable of conveying various types of information as different visual states to its spectators. The physical pixels can be activated kinetically. The physical pixels can also be controlled in terms of levels of illumination to create low or high resolution digital screens. The technique involves the conception of the illuminated pixel as a node with a binary condition, or a node that is capable of illuminating gradients of light intensity in various colors. Thinking of the built environment in terms of informatically driven layers of individual pixels, capable of forming individuated yet synchronized responses to the changes in their context, has its roots in our understanding of digital culture. Let us step back and momentarily and try to understand these roots. In a 2004 article published in Damus magazine titled Alternative Digitality, Bruno Latour defines digitality as the transformation of everything into a series of zeros and ones. This interpretation of digital realm corresponds to the 90s epidemic of faith in the possibility of replacing the actual with the virtual. This vision even encompassed fantasies about uploading human consciousness to the realm of cyberspace as manifested in cyberpunk and sci-fi literary genre, where the space of the future has no physicality but consists of only digitally encoded transactions. For example, William Gibson's 1984 novel, Neuromancer, is a seminal work in the cyberpunk genre. Thanks to Neuromancer, the term cyberspace gained recognition to become the de facto term for World Wide Web during the 1990s. The portion of the novel usually cited in this respect is, and I quote, cyberspace, a consensual hallucination experienced daily by billions of legitimate operators in every nation, a graphic representation of data abstracted from banks of every computer in the human system, unthinkable complexity, and it goes on to, the text goes on to basically equate the idea of cyberspace to city lights receding in the perspective. In Neuromancer, the urbanites are envisioned as processing a brain-computer interface that allows them to access the global computer network in cyberspace, creating a virtual parallel world that they find as real as, even more real than, the physical world that they are living in. Yet, despite technocrats' obsession with the vision of an all-digital world, during the past 2 decades, an approach has emerged where digitality lends a new materiality to everything by augmenting the material with the virtual, or the so-called zeros and ones. The digital did not kill the physical as fantasized during the 90s. In fact, the digital and the physical are recombining, or in the word of Hiroshi Ishii, the bits and bricks are marrying. Once bits of information become tangible, they can be considered building blocks of our inhabitable spaces, so that the gap between cyberspace and physical space is bridged by digital technology, and thus bits and bricks are married in a new paradigm shift in the realm of spatial practices. We can see such a conceptual leap manifesting even in the literary genre of sci-fi and cyberpunk. There has been a gradual abandonment of the dystopian vision of disappearing human built environments to virtual means instead of substituting them. In the book, When Things Start to Think, Neil Gershenfeld contemplates this idea of virtually augmenting the physical world, discussing a world in which everyday objects and devices are endowed with computational power that enables them to exchange information about our identities, abilities, and actions. What if we focus not on standalone objects, but overall environments and architectural spaces that not only are able to think, but also are able to talk to? We need to learn how to add computational power to spatial phenomena in order to enable them to talk to each other and to the people inhabiting this space. And also to function as a medium through which the inhabitants of space communicate amongst themselves. We call this specific taxonomy of a space a sentient space. It is worth mentioning that a sentient space is a monitored space by definition. Any action initiated there by the spatial elements or arrangements is conceptualized as a response or reaction to something happening in the space. Therefore, first of all, the space should be monitored with sensors that enable the system to detect changes in parameters. Then this monitored space is actuated or animated in response to those changes. For this, as designers, we need to consider a range of physical actions within the atmospheric phenomena that computers can sense, interpret, and respond to. But before that, let's refine our understanding of cultural phenomena that we address as digitality. Digitally augmented spaces that become sentient are hybrid entities in terms of spatiality. In the conception, the designer acknowledges the existence of two spheres, the hands-on material sphere and the infosphere populated by digitized annotations of the process of the material sphere. Yet, she must further address the question of what happens when these layers meet at points that I define as information touchdowns. These are the interfaces for accessing information and interacting with the rhizomatic global web of information. In our experience of the world, we know that material things cannot be dynamically customized according to what is happening in the infosphere without the interference of what can be characterized as mediators. We are aware of general holdups in eliminating the mediators. Among these are our preconceptions, such as assuming that computing is what happens when a user is in front of a computer screen, typing characters on a keyboard, or manipulating virtual entities with a mouse. We also know the limits of materiality as the substantive world, and how initiating change in this world is costly, time-consuming, and always constrained by rules of physics. The design for a digitally augmented space starts at the point where these preconceptions are violated, and where the material world changes its nature in terms of reconfigurability, and it is at these interfaces where a physically mediated infosphere meets a digitally mediated material sphere, and they co-mediate and correlate with each other. And this is where we arrive at the critical subject of design, which is the design of that point contact, which facilitators substantialize these virtual series into physical action that the subject can perceive through vision, audition, olfaction, thermoception, tactility, or even gustation. The fundamental issue to address is, when the physical and digital worlds are apparently manipulatable, how can designers design for a world of cross-manipulation? This presents the prospect of a space of cross-reality. In a world of cross-manipulations, particular words, concepts, and technologies acquire certain cultural buzz. We can track such trends in various cultural productions during recent years. The aforementioned books and hundreds of others have speculated about the prospect of a world of unlimited computation, embedded technologies, and hyperconnections. Let's think for a moment about the impact of this conceptual leap on the urban condition. Take urban circulation as an example. In the previous model, safety required the slowing down at intersections. Traffic rules dictated driver behavior, while traffic signals, pavement markings, and other indicators helped to prevent collisions. In the present model, the need for speed has given rise to space-consuming chunks of concrete in our infrastructure of mobility. Large numbers of cars move in all directions simultaneously, while big curves let you change directions safely and smoothly. In this model, a lot of space that is required remains empty and useless. In near future, through the application of smart technologies and embedded computational algorithms, our infrastructures or mobility can become aware of their context and transform to responsive, self-adapting mechanisms where concrete and signage are soaked up by novel technologies at work. To this effect, the layout of the road will be determined in real time and dynamically based on the considerations of required capacity at any given situation. If all the vehicles in an intersection are hooked up to a pervasive networked control mechanism through which global calculations are performed by a central control and command mechanism and relate to each individual vehicle, a calculated speed and course will make you cross the intersection without stopping and will eliminate the need for additional urban signage and substantial infrastructural components. In an extreme variation of a somewhat further future, the linearity of urban circulation is lost. The urban landscape is cut up into motion space and obstacle space, where people and public events will coexist safely and efficiently with the high-speed urban commute. oriented. In a modernist reading of a function-oriented space, those who are contained and sheltered within these spaces are inhabitants of the space. In an operation-oriented space, they are users, and of paramount importance is the design's ability to solicit their interests and desires and answer emergent requests that at times may not even be clear to the designer during the initiation period. The user is not the ideal subject of Vitruvius. She is not even the modular, rationalized subject of Le Corbusier. She is the iPhone woman with a smartphone that allows her a constant contact and interface with the city that she inhabits. An individual expecting customization instead of an all-in-one perfect response of functionalism. The operation-oriented space that accommodates the perpetuation between non-substantive constitutive elements of the space, the subjects inhabiting the space and the objects constituting the space or existing within it. And of course, spatial narratives and scenarios enacted by the subjects, digitally encoded information about the processes with the space and the time in which these interactions occur. Designing for such a space is by definition designing for interactions. In the traditional approach, the discourse of interactive design focuses on two components of the discipline, people and technology. In rethinking interactive design as a discipline concerned with technologically enhanced spatial scenarios, we can add the third element of space to make the triad of space, people, and technology as a new discipline. The interactive scenarios in a digitally augmented space happen amongst the space, the subject inhabiting the space, and the technology that augments both. The question to address then is, what is the nature of this third element, the space of interaction? An interactive entity is by definition a sentient entity, able to feel, see, hear, smell, or taste. It is able to perceive or feel things, and it is responsive to or conscious of sensory impressions. An interactive entity may also be a kinetic entity, as it is by definition an active entity whose actions are formed in reaction to some sensed stimuli. An interactive entity can also be enhanced to become responsive, or it can be adaptive, which means showing or having the capacity to change to fit to some purpose or situation. At its utmost order of sophistication, an interactive entity can also become an intelligent entity, revealing or reflecting good judgment or sound thought, and able to learn and understand things or to deal with new situations. Interactivity is all about data and data-driven performance. In the design and implementation of an interactive piece, the first step is to come up with an appealing scenario. What is it that you want your piece to do? What feature of the environment you want your system to be responsive to? What physical property of your environment you want to sense or measure? Which sensor are you going to be using to measure this feature? Which feature of the environment you want to change based on the sense data? Which actuator you need to initiate such a change? And finally, how do you want to relate to the input to the output to make your system responsive? Any interactive object or space is made up of three elements. First is the physical interface, the stuff that you touch, hear, or see. Second is the software interface, the commands that you send to the object or a space to make it respond. And third is the electronic interface, which consists of the electronic parts that communicate with the system and each other by sending and receiving data in the form of electrical pulses mediated by microcontrollers. A microcontroller has no physical interface that humans can interact with directly. It is just an electronic chip with input and output pins that can send or receive electronic pulses using a microcontroller is a three-stage process. You connect sensors to the input pins to convert physical energy like motion, heat, and sound into electrical energy. Then, in the second phase, you attach actuators to actuating pins like light-emitting fixtures, motors, speakers, and other devices. And these would be connected to output pins to convert electrical energy into physical action. And finally, you write a program to determine how the input will change the output, which basically means you will be reading the changes in the input data and applying changes into output data. Hence, everything that you sense from and send to an environment is in form of data. And cybernetic cross-mediation between what is sensed and how the responsive entity is actuated is made possible only and only if this data is properly digitized and converted to machine-readable format. Hence, the strong relationship between digital culture and emergence of responsive entities at artifactual, architectural, and infrastructural scales seems substantiated by the very definition of interactive and informatically driven performance that is expected from these entities. When I started this portion of the talk, my historical references did not go beyond what was happening in the 90s. But if we want to be more rigorous in establishing the theoretical ground for what we just pinpointed as operational or performance-oriented approach towards artifactual infrastructure, explorations need to go even further back. Perhaps a good start would be the birth of cybernetics as a discipline. Cybernetics was defined by Norbert Wiener in his book of the same title as the study of control and communication in the animal and in the machine. It can be described as the science of effective organization with the goal of optimized performance and efficient operation. The intellectual roots of cybernetic view can be traced to the Enlightenment's ideological shift from a natural to a mechanistic worldview represented by Descartes' interpretation of natural organisms as automata. This allowed man to reconsider the origins of life, since any living organism was a machine with identifiable rules of operation, and man could create complex mechanical systems, then the ability to create life was no longer the domain of the Almighty, meaning man could now start considering the creation of machines that would simulate live thinking mechanisms. A few decades later, in 1822, Charles Baggage's proposed machines would advance man's quest to create life towards the automated actuation of the physical world. His mechanical control systems could be considered the precursors of today's computers, and one could perhaps claim that Baggage's difference engine was the first cybernetic mechanism, although perhaps although it is worth mentioning that the feedback between the system's output and input was mediated mechanically instead of electronically. Following that, cybernetics officially emerged with Norbert Wiener and his principle of expanding human control over the environment via electronic interfaces. Born French artist Nicolas Schuffer can be considered the father of cybernetic art. All of his creations are done in pursuit of dynamism in art. This interest in artistic dynamism was originally initiated by the Cubo-futurists and then intensified and solidified by Russian constructivist artists. All these artists were concerned with opening up the static three-dimensional sculptural form to a fourth dimension of time and motion. This was the intention of Schufer as well. For example, the spatial constructions of Russian constructivist Alexander Rodchenko are physical compositions meant to create spatial settings of non-substantive nature. The space created in the abstract relations of the floating elements transforms into what can only be characterized as space-time, a conception of space that allows for a fourth dimension, which is that of time, in which the space is allowed to transform. In Rodchenko's art, the object continuously reconfigures itself. A space is not an absolute extension within which things stay fixed, as is expected from conventional architectural spaces, but it is in constant negotiation with gravitational forces. Here, a space defies gravity by allowing the objects within it to float. The void that happens in between the floating objects is itself a part of the overall composition. Schufer, however, coming well after, benefited from cybernetic theories of feedback systems and interactivity based on the ideas of Norbert Wiener. These theories suggested to him artistic processes in terms of organizing the system for manifesting concepts such as circular causality or feedback loops. For Schufer, this enables the cybernetics to elucidate complex artistic relationships from within the work itself. Later on, Gordon Pask extended the vision of a feedback loop to include information flows in all medias from stars to brains. In a 1969 article called The Architectural Relevance of Cybernetics, he literally expanded the intellectual domain of cybernetics to architectural discourse. He maintained that architecture is a system and architects are system designers, and if conceptualized as a system, architecture should be designed and implemented to accommodate evolution and notion of change due to adaptation. This is how Pask envisions architecture that functions as a cybernetic mechanism. One can say that thinking about architecture as a cybernetic system, the designer can conceptualize scenarios in which a space is modified in the following ways. First, it is monitored using digital sensing. Second, it is conditioned through computational processes based on detected change in the monitored spatio-temporal factors. And third, it is actuated through embedded virtual or physical agents that provoke changes that are detectable by the subject. The next step was ubiquitous computing. Ubicom names the third wave of computing. It is the age of calm technology, when technology recedes into the background of our lives, and in the words of Mark Weiser, who is the father of ubiquitous computing, he talks about the idea of integrating computers seamlessly into the world in a seminal paper of 1991 titled The Computer of the 21st Century. He maintains that the most profound technologies are those that disappear. They weave themselves into the fabric of everyday life until they are indistinguishable from it. He proposes the term embodied virtuality to refer to the process of drawing computers out of their discrete places and into the environments that host our day-to-day life experiences. Although Gordon Pask is acknowledged for initiating this conceptual marriage between the two disciplines of architecture and cybernetics, Cedric Price's proposal for the Fun Palace was perhaps one of the first examples of an architectural cybernetic system to incorporate Wiener's feedback principle. New technologies of time made the Fun Palace responsive to visitors' needs, dynamically adapting its spatial configuration. The proposed building was a kit of prefabricated modules that would constitute a variable structure which Price claimed could be assembled, moved, rearranged, and scrapped continuously. It is worth mentioning that Gordon Pask and Cedric Price collaborated on developing the technological aspects of the design concept for the Palm Palace project. The vision of architectures capable of soliciting their inhabitants' control over the production and consumption of space also prevailed in Una Friedman's 1954 mobile architecture. It could be said that all of the above work, dating back from the mid-20th century, already contained most of the key principles of designing responsive living environments. However, they lack the effective communication infrastructure necessary to acquire global relevance. And by that, I mean the digital network. Later on, John Fraser, who had collaborated on various projects with Cedric Price, added this important aspect to architectures designed as complete cybernetic systems. The capacity for networked behavior and the transmission of digitally encoded messages amongst a multiplicity of constituting elements. In the 1990s, a group of his students developed the working prototype of such a networked cybernetic model called the Universal Constructor. The model was a self-organizing interactive environment consisting of a series of stackable cells, which each unit contained an integrated circuit to communicate its status to a central control and command mechanism, as well as its neighbors. So with that, we can now claim that we are able to create sophisticated, distributed, dynamic, interactive cybernetic mechanisms capable of responding according to a rule-based data architecture. What are the consequences of these transformations that we have followed in detail? This question can be addressed in several layers, but I would like to make note of its influence on the design of a city. I think that under such circumstances, we are going to be able to create cities that are cybernetic systems, cities that are sensed, conditioned, and actuated, cities that can respond to emerging conditions as a real-time system. They told me that I just have 5 minutes, so I'm just going to go for just going to need some second too. Okay. In designing for digital augmentation, though, the designer should recognize the fine line between that which is strange and awe-inspiring, provocative and astonishing, and that which is overdoing the use of technology and threatening to turn the project into a science fair or a piece of circuit porn, which will lose its appeal once the novelty of the technology wears off with the introduction of more advanced technologies. Considered in Peter McFarlane's circuit board sculptures, which combine a conceptual notion of ancient history with the not so distant past. His circuit board fossils draw attention to our rapidly changing society, where yesterday's technological innovations quickly become obsolete and their remnants thrown into the trash as technology moves onto the faster and better model. The sense of wonder that a digital augmentation scenario can generate requires novelty, but one should make sure that the novelty is not limited to the technology that is showcased. There is a fine line between an appealing, digitally enhanced spatial scenario and a mere science project. The novelty should be in the vision that the designer has for the narrative expressed through the technological constructions. If novelty were limited to the technology itself, when the technology inevitably becomes commonplace and outdated, the realized object or space would no longer provoke a sense of wonder. To provide a counterexample to the technological piece whose provocation outlives the novelty of its technology, I would like to refer to David Nye's work on technological sublime, where he argues that the success of a technological construct is the possibility of repeatability of the experience. As proof, he offers the example of Brooklyn Bridge, and citing that although at the time of its erection, the crowd appreciated its technological feat, the experience offered by the bridge as a spatial construct is not limited to the technology of its construction. The Brooklyn Bridge continues to provide users with a moving experience and an innovative spatial narrative due to the multiplicity of viewpoints and impressive perspectives that it offers, which is evident in Walker Evans' photographs of the bridge of the time. For me, the BMW kinetic sculpture is in fact an example of the use of a very precise contemporary technology to create an experience whose novelty has the potential to outlive the novelty of the technology that enables it. The field object is a platform for the materialization of digital information. It is a metaphorical translation of the process of form finding in art and design. 714 metal spheres hanging from thin steel wires attached to individually controlled stepper motors and covering the area of 6 square meters animate a 7-minute-long mechatronic narrative. In the beginning, moving chaotically, then evolving to several competing forms that eventually resolve to the finished object. The kinetic sculpture creates an artistic visualization of the process of form finding in different variations. The beauty of mathematically driven curvilinear form is not dependent on the technology that allows for the realization of this piece. And it is on this note that I would like to finish my presentation. Thank you for your attention, and sorry for it being a bit long. I don't think that they're on.
Hello. Thanks for the lecture. It was very interesting.
Thank you.
And actually, I guess it sums up a lot of the topics that we are going to explore. So the hyperspace, the cybernetic machine, the augmented citizens, and then how we evolved from machine computing to ubiquitous systems. They are now connected also to the body. So I guess as a starting lecture, it was a great sum up. I personally thank you for all the bibliography that you share, and I guess it can be a good resource for all the other students that to use and to get information from. So from Barcelona side, I guess it's done. More or less, it was a success, apart from some problems that we have at the beginning. So, but absolutely a great start. So thank you, and I saw that you show an image of Yona Friedman. We will have Yona on Wednesday, so tomorrow I'll be checking all the connection with him. And yeah, looking forward to see you again on Wednesday. Okay, so thanks for all the other notes. Bye.